Today, we are going to be working with the spectrophotometer.
I am doing the cubet for purpose. Only get a little bit of the dye. Make sure that your dye does not go over the mark. You don't want too much reagent.
Okay, we're going to prepare our first cuvette with the dye we extract. Now we're going to dilute it with water, a solvent.
We're going to make the blank with the solvent.
Okay, before you start your spectrophotometer, always make sure that's 0, or that it's close to 0. This is working. When you get your cuvette, make sure that you wipe 2 sides completely clean. Like this, 2 sides. Open the scanner, and make sure that you put your cuvette in the sides that are clean. Close up. Now close the scanner before you read it. And then set to start. And make sure that you name the thing. You can name it whatever you want. Okay. And then you read it just like that. And that will be the wavelength that you have. And then closing it. Okay, so why is it important to scan across all wavelengths? Scanning across all wavelengths helps us to identify the components that are in a substance, if there are multiple parts, and it also can help us when we're trying to figure out a specific wavelength to measure. This wavelength is usually the lambda max. So if you look right here, the lambda max, this is where the substance absorbs the most amount of light. So this is going to be the most effective place for us to measure our absorbance. That'll be the best wavelength for us to pick. So this is why we need to scan across all of them so we can most effectively determine, since certain substances will have different lambda maxes. Like this one's significantly high. And this is why it's important to scan across all of them.
The pure Lambert equation is A equals ECL. A is absorbance, C is concentration, E is molar absorptivity, and L is path length.
Absorbance is found by measuring a substance at a specific path length, and the molar absorptivity is like the highest possible absorbance that a solution can have. And concentration is found by dividing moles by liters. So you'll want to find your moles from density, which is grams per liter, which is just dependent on the substance, and then you convert grams to moles. Absorbance and concentration are proportional to each other. So if concentration increases, absorbance will too. If you fail to zero your substance when you put it in the spectrophotometer, it'll stay on another absorbance, which will affect the equation for all of the other absorbances you measure. So it'll be completely wrong if you do not zero it first. Once you get done with your cuvettes and all your wipes, make sure you take all your cuvettes back and throw away all your wipes so we do not make a mess around the thing. And